So now that our waveforms are labeled, let's talk about interpreting them. So when we look at cVEMP responses, or even oVEMP responses, our waveforms, and this works for either way. So, if I'm talking cVEMP, oVEMP here, it's interchangeable kind of in a sense, because these are very, very similar responses. They're just flipped, and oVEMPs are much smaller, whereas cVEMPs are larger. But when we're looking at this, we're really looking at a comparison of the amplitudes, or how tall they are, between both sides. And so right now, clearly you can see that this left one is much larger than the right one, but by how much? Here's how we're going to do that. I'm going to double click on one of the waveforms, and then I'm going to move to the other one over here, and I'm going to right click on it. When I do this, I have my options I mentioned already, hiding and deleting them. We don't want to do that, but I can set as a VEMP partner, which is what I want to do for both of my types of VEMPs, cVEMPs or oVEMPs, in this case oVEMPs. So I'm going to set that as a VEMP partner. What you'll see over here off to the left when I do that is this 0.60. This is a 60% difference between my right and my left, with my right being much smaller than the left. And so typically that means that the right ear is going to be the lesioned ear, or the ear that is causing the problems for our patients and creating the symptoms that they're experiencing. It's originating typically from the lower amplitude ear. Not in every case, but most of the time that's the case. And so a 60% difference is pretty significant. You'll hear different numbers based on the literature that you're looking at, anywhere from 35 to 40%. If it's higher than that between ears, then that would be considered abnormal. So again, our latency really isn't what's important here. Our amplitude is really what's more important, and really the amplitude between both ears. And so we're looking at the 60% here. So that's clinically significant in this case. If I go up here, I want to show you a couple of other things. You can look at your latency values. So really the things I'm looking up here are my P1, N1 under the milliseconds. These are going to show me my amplitude values, my latency values, how long it is. So remember, with oVEMPs, we're expecting roughly 10 to 13 or 10 to 15, depending on who you're looking at. Again, latency isn't the most important factor, but it does help us identify where this response is happening. And so for my N1, I'm at 11.33, P1 at 17.00, a little bit later than what's typical, but I wouldn't consider this significantly abnormal. Whereas if I double click on the right one, you'll see that these numbers change a little bit. This is closer probably to the 10, 15 millisecond rule, but we're at 11 and 16 here. It's a little bit more stretched out. Whereas this left one is a little bit more peaky, but you can see just a few little latency differences here. But again, the amplitude and the amplitude ratio between your ears is really the more important finding. And so again, to do that, you would double click on one, right click on the other, and you would set your VEMP partner in order to do this. And so this is really the big thing you're going to do for both oVEMP and cVEMP, but in this case for our oVEMP responses.